Let's learn about gradient. To introduce gradient, I have two lines here, line A and line B. I want you to think, look at these two lines. Which line is steeper? And can you measure how steep it is? Well, we have a strategy for measuring how steep it is and for proving the answer to question 1 rather than just looking at it and having a guess. And the strategy is called using its gradient or slope, and that's the steepness of its line. A bigger gradient means that it is steeper. Gradient and slope are the same thing. The symbol for gradient or slope is m. There's a long history of why it might be m. The truth is we don't really know. It might be related to the French. Ask me another time, I'll tell you all about it. To find the gradient, the slope, we use this formula. M, which is the gradient, is the y step divided by the x step. The y step is how far up or down you go, and the x step is how far left or right you go, the horizontal distance. To use this formula to get this distance between the points, we need to plot 2 points that are on the line. So for example, for this line A, I might put a point here and a point here. Maybe you might have picked 2 different points, like here and here, or here and here, as long as you pick 2 points on the line. Once you've picked 2 points on the line, then you can use the formula. Interestingly, no matter which 2 points on the line, you'll get the same answer. We'll all get the same answer if we all pick a different pair of points that are on the line. But to make life easier for you, I would suggest not picking a point like this, if you can avoid it. Because it's in the middle of nowhere. And this one is the same. It's not on the intersection of the grid lines. Like this point here, it goes right through where the grid lines cross each other, where they intersect. So I would suggest picking 2 points that are on grid intersections to make your life easier. As an example, if we want to find the gradient of line A, then first I write my formula, m equals y step over x step. I look at my 2 different points. And do you notice that I can go, to get from this one to this one, I can go across and then up. I can go across and then up to get to the other point, which helps me figure out how far across I went, the horizontal distance, that's your x step, and how far up you went, that's the y step, the vertical distance. The horizontal distance here, how far across? I went 2 units across. How many units up did I go? I went 3 units up. So, therefore, that's what this symbol means, therefore, m equals the y, I will put my fraction line in, the y step is how far up I went, the vertical distance, in this case the vertical distance is 3, and what is my x step, how far across did I go? 1, 2. Good. If the line is uphill, the slope is positive, this line goes uphill, so the slope is positive. Let's do this one, find the gradient of line B. By the way, you can, if you want to, you don't have to, this answer is fine, it's a simplified fraction. You can, if you want to, write it as a decimal, if there is an exact decimal, and in this case there is. 3 divided by 2 on your calculator is 1.5. So the slope is 1.5. Let's find the gradient of line B now. Again, I need to plot 2 points that are on the line, and it's easiest if they're on grid intersections. So maybe I'll pick this point and no, not really on a grid intersection. This one, there we go, this one lies on a grid intersection. So I'll pick these 2 points. I'll write my formula, m equals y step over x step. I will go across and then up. Sometimes you might need to go across and down. But in this case, across and then up. How far across did I go? I went 3 units across. How far up did I go? What was my y step? 1, 2, 3, 4, 5. 5 units. So now I will write this formula again, but instead of y step, I will write the vertical distance, which is 5. And instead of x step, I will write the horizontal distance, which is 3. So m is 5 over 3. I won't be able to write a perfectly exact decimal for this. If you put 5 divided by 3 in your calculator, you'll get 1.66666666666 and so on. So I'm going to round it off to 2 decimal places, which is 1.67. And do you notice that I use this symbol? This means approximately equal. It means that I've rounded it off, and this isn't the exact answer anymore, but it's close. You might notice now that we can answer the question. Which line is steeper? Line B. The slope is 1.67, but the slope of line A is only 1.5. Okay, let's try a few more just to get practice with different lines going in different directions. What if it's horizontal? Things like that. Question. Find the gradient for each line. So, this line here, I write my formula. I pick 2 points on the grid intersection. I could pick here and here, or here and here. I'm going to pick this point and this point. I go look at how far across and up I go. This one, I go across 2 units. So my x step is 2, and I go up 4 units. 1, 2, 3, 4. So my y step I replace with 4. 4 divided by 2, that is a whole number, so I should simplify it. This is not nice for a finished answer because it's not simplified. Let's simplify it. 4 divided by 2 is 2. For an uphill line, the gradient is positive. What about something like this? It's a horizontal line. Well, we can do the same thing. The gradient is y step divided by x step. I can pick 2 points, this one and this one. I can look at my y step. How far up or down do I go to get from here to here? Well, I don't go up and I don't go down. I move 0 units in the vertical direction. In the horizontal direction, I move 1, 2. My x step is 2. My y step is 0 because I did not move in the y direction. I did not move up or down. 0 divided by 2 is 0. So for a horizontal line, the gradient is always 0. There's a little shortcut for you. If you see a horizontal line, you can say the gradient straight away. Let's look at this line now. For this one, I can pick 2 points that are on the grid intersection. So maybe this one here and this one here will work. I write down my formula. I start at this point. I go across and then down. My y step is how far up or down I went. Did I go up or down to get from here to here? I went down, right? And I went down 1 unit. So it's negative because I went down. The y step is negative, -1. The x step, I went across 1, 2, 3. So it's -1 over 3. All downhill lines will have a gradient that is negative. It's going down. And finally, we have a vertical line here. We can do the same sort of thing. If I pick my 2 points, like here and here, the x step, well, I don't go to the left and I don't go to the right. I don't go across at all. So my x step is 0. My y step is 3 because I can go up 1, 2, 3. So the y step is 3. The x step is 0. What's 3 divided by 0? It's undefined. It doesn't have an answer. You can think of it sort of like infinity, but instead of saying infinity, we say that it's undefined. It has no proper answer. So for a vertical line, the gradient is undefined. And you'll just say that. The gradient is undefined. Cool. I hope this has been helpful. I've got one bonus thing if you're interested. If you don't care about what gradient means, then you don't have to watch this section. You can just stop watching and get into it. But if you are interested why we're doing this, what gradient actually means, I've got 3 different graphs here. This one is a container filling up with water. And that 1 looks like it's in the wrong place. It doesn't matter. The 1, that's a little error. The 1 should be there, the 2 should be there, the 3 should be there, the 4 should be there. Woo! And this one, the 1 should be there, the 2 should be there. Woo! The 3 should be there. That should be 4. Woo! What a schmozzle. That's 5. The numbers don't really matter too much. So this has a container filling up with water. And after 1 hour, it has 2 liters of water. After 2 hours, it has 4 litres of water. This container is filling up pretty quickly. The gradient is 2, and it's filling up with water at 2 litres per hour. That's how fast the amount of water is changing. Here we have a meteorite falling to Earth. It starts at 6 kilometers from Earth, 5 kilometers after 1 minute, 4 kilometers after 2 minutes. It's falling down. Here, the gradient is negative. It's -1, actually. And this means that it is the distance from Earth is falling at a speed of 1 kilometer per minute. So gradient gets a graph and tells you how it's changing. This is a graph that I was confronted with when I had my daughter. Her baby weight, you weigh your baby fairly often at the doctor's in the early days. The nurse comes around to your house and can weigh your baby, that sort of thing, because that's a real indicator of how well they're going and how well they're growing. And you can get really, really worried if they're losing weight quickly, for example. I know that I was really worried. And this graph, when you look at it and figure out the gradient from here to here ends up being -75. When you look at this as a new dad, you haven't had a kid before, you think, oh, this is really steep. Is this really bad? Well, you can calculate the gradient to get a number to see if that is good or bad, or if it's a problem or not. And the gradient says that the baby weight is going down, because it's negative, at 75 grams per day. So in 1 day, it goes down by 75. I do apologize, the alignment of these axes is really messy and off, but you get the idea. There are some formatting problems. So the gradient tells you how fast something is changing, and it says if I move across 1 unit, how much does it go up or down? If I move across 1 unit, this goes down 1, hence -1. If I move across 1 unit, this goes up 2, hence the gradient is 2. If I move across 1 unit, it goes down 75, hence the gradient is -75. Cool. Anyway, good luck with the gradient questions. Let me know if I can help you out. Bye, everyone.